Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 22 to 27, which account for 22 of these marks. AQA paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 22. A equals root 2 and B equals root 18. Match each expression to its value. One has been done for you. Okay, so to start off with, what I'm going to do is I'm going to simplify B. So root 18 can be simplified to 2 times 9, which is root 9 root 2, which is 3 root 2. So that's my B value simplified. So let's start substituting in some values. So A squared, so root 2 times root 2 is going to be 2. Already matched up for us, so we're just checking we know what we're doing. A plus B. Root 2 plus 3 root 2. 1 root 2 plus 3 root 2 is 4 root 2. So we're going to match A plus B to 4 root 2. A times B, so we're doing root 2 times 3 root 2. So root 2 times root 2 is 2. So we're going to do 3 times 2, which is 6. And then B divided by A, so 3 root 2 divided by root 2. We're going to cancel those roots. B divided by A is 3. Question 23. Write 0.13 recurring as a fraction in its simplest form. So I'm going to start by expressing x as 0.1333, and obviously it would continue. Now I'm going to get another version of x, but I want the decimal to match as much as possible. So I'm going to get 10x to start off with. So 10 times x, if x is this, would be 1.333, and that would keep going, that would keep recurring. Now, what I'm aiming for is for them to match on the right hand side here after the decimal point. They don't at the minute, so what I'm also going to go with is 100x. So x times 100 would be 13.333 recurring. So what we can see with these two values here is that we have the same digits exactly recurring after that decimal point. So these are the two versions I'm going to use. So 100x subtract 10x is what's going to happen now. So 100x subtract 10x is 90x. So then 13.3 recurring subtract 1.3 recurring. Well, the 0.3 recurring is going to cancel out, and 13 subtract 1 is 12. And now it's a case of solving for x to write it as a fraction. So x equals 12 over 90. We want it in our simplest form, so that's 6 over 45. Both still in the 3 times tables. So that's 2 over 45 divided by 3. 50. 2 over 50. Question 24. Points P, Q and R, and R's coordinates are given there, form a triangle. PQ is a horizontal line with P on the y-axis, which is here. Angle PRQ is a right angle. The gradient of the line PR is 2. Work out the coordinates of Q. So we're first of all going to work with this piece of information here, knowing that the gradient of PR is 2. So if I was to draw a line down there, the gradient would be the change in y divided by the change in x. The change in y we don't know yet, but the change in x, if this is on the axis it's at 0, and then across to here is to 8. So actually this distance is 8. So we will have done something divided by 8 to get this gradient of 2. So 8 times 2 is 16. So that tells me that that distance there is 16. If this distance here is 16 and the y coordinate there is 22, 22 subtract 16 is 6. So it means that Q has a y coordinate of 6. So now it's simply a case of trying to find the x coordinate. So we're going to find the x coordinate by finding the equation of the line RQ. So we were told that the gradient of the line PR is 2. Well, the line RQ is perpendicular to PR because of this right angle. So it has the negative reciprocal gradient of PR. So if PR's gradient is 2, then the gradient of RQ is negative a half. It's the negative reciprocal. So now we can form an equation for the straight line RQ. So y equals negative a half x add c. Now we know a set of coordinate points on this line RQ. They've given us r. So let's substitute those in. So x equals 8 and y equals 22. That's from that r coordinate there. So y equals 22. X equals 8. So negative a half times 8 is negative 4. If we add that 4, c must be 26. So if we rewrite this equation, y equals negative a half x plus 26. So this is the equation of the line RQ. So now we can use this equation and the part of the coordinate we know for Q to find out the x coordinate. We know what the y value is. We're looking for the x value to complete that coordinate. So we're going to substitute y equals 6 into this equation here. And it's because we know Q's got a y coordinate of 6. So 6 equals negative a half x add 26. If we subtract 26, so 6 subtract 26 is 20. And then we're going to divide by negative a half. So when we divide by negative a half, it gives us negative, oh no, that's negative 20. So when we divide by negative half, it gives us positive 40. So x is positive 40. So this is the x coordinate. So Q has an x coordinate of 40 and a y coordinate of 6. Question 25. Show that 4 times sin 30 subtract tan 45 divided by 2 cos 30 can be written as tan x, where x is an acute angle. So we need to use our exact trig values here. How you generate these is up to you, whether you use the table, whether you use the hand method, whether you just remember them. But we need the exact trig value for sin 30, tan 45 and cos 30 initially. We'll also need to know what tan x equals, but we can deal with that towards the end of the question, where x is an acute angle, so x needs to be less than 90. So that's worthwhile bearing in mind. So exact trig value of sin 30 is a half. The exact trig value of tan 45 is 1. And the exact trig value of cos 30 is root 3 over 2. So now we're going to substitute these values into this calculation. So we've got on top 4 times a half, that's 4 times sin 30. Subtract tan 45, which is 1. And that's all going to be divided by 2 times cos 30, and cos 30 is root 3 over 2. Okay, so 4 times a half, that's 2, subtract 1 on top. 2 times 3 root 2 becomes 2 root 3 over 2. So now we can simplify the top and the bottom further. 2 subtract 1 is 1. 2 root 3 divided by 2, leaves us with root 3. So this calculation is 1 over root 3. Now I know from my exact trig values that 1 over root 3 is the exact value for tan 30. If you'd have generated it using a table, then you would have been able to recognise that value if you didn't know it off by heart. So 1 over root 3 is equal to tan 30. 30 is less than 90, so that's an acute angle. So it can be written as tan x when x equals 30. And then we've done that question. Question 26. A circle, centre O, has a circumference of 20 pi centimetres. Q is a point on the circle and OPQR is a square. It being a square is important because we need to remember the properties of a square. So the ratio of the perimeter of the square to the circumference of the circle is equal to root A to pi, where A is an integer. Work out the value of A, you must show you're working out. So if we want the perimeter of the square, we need to know the length of the square so that we can then find the perimeter. We've already been given the circumference of the circle, so we've been given the second part of that ratio there. So let's start thinking about how we can use the circumference of the circle to find out the lengths of this square. Well, O to Q, so OQ is the radius of the circle because it tells us that the centre is at O. So if we're going up from O to Q, that must be a radius. Okay, we know that the circumference is 20 pi, and to work out the circumference, we would do pi times the diameter. So if the circumference is 20 pi, then the diameter must be 20. If the diameter is 20, then the radius is half of that, so the radius must be 10. So OQ is 10. Now I can use that information to find out the side length of the square. Now remember, 4 equal sides for a square. So I'm just going to take this bottom right angle triangle of the square. Let's call these two sides x. They are both equal length, so I can call them by the same letter. And I'm going to use Pythagoras to find out what x should be. So the shorter side squared, so x squared plus x squared should equal the longer side squared. So we're forming an equation right now. So x squared plus x squared is 2x squared. 10 squared is 100. So x squared is equal to 50. So x is equal to the square root of 50. Now I'm going to simplify the square root of 50. So that can be 25 times 2, which is root 25 root 2, which is 5 root 2. So this is now the side length for the square. So I can find the perimeter. The perimeter is all the way around the outside of the shape. I've got 4 equal sides, so the perimeter of the square is equal to 4 times 5 root 2, which will be 20 root 2. So now we're going to use the circumference of the circle and the perimeter of the square because that's what it asks for in our ratio. So let's write them as a ratio as we currently know them. So perimeter of the square first, 20 root 2 to the circumference of the circle, which we know is 20 pi. So now we're going to simplify this ratio and we're going to try and get it into this form. So I can divide both sides by 20, which leaves me with root 2 to pi. So the right hand side of the ratio matches. The left hand side matches in terms of we've got a root, and that tells us that actually the value of A must be 2. Question 27. A journey has 2 stages. So we've got distance, speed and time for stage 1 and stage 2. show that the average speed for the whole journey in kilometres per hour is this expression here. So if we want the whole journey, we need the total distance and the total time. Speed, distance and time. If we're working out speed, we need total distance and total time. So the total distance is 30 add 30, which is 60 kilometres. There's kilometres here, and let's just check that it matches the units we're using for speed, so that's good. The total time is 30 over A add 30 over B. So to find speed, we will do distance divided by time. So speed equals the distance, total distance of 60, divided by the time. So we're going to deal with this fractional part first. So it's an addition of two fractions. So we need a common denominator, then we can represent it as one fraction. So it's going to be 60 divided by, I'm going to multiply this fraction by b. So it will be 30b over ab. And then I'm going to multiply this fraction by a. So it'll be 30a over ab. Now we have a common denominator. We can write them over that common denominator. So 30b plus 30a over ab. So now it's a case of simplifying this as far as we can go. So we're dealing with a division. So let's write this as 60 over 1 so we can think about dividing fractions. So when we divide fractions, we're going to keep the first the same, and then we're going to find the reciprocal of this. So we're going to flip it upside down. And now it becomes a multiplication, which we can then write as 60ab all over 30a add 30b. Remember, it becomes a multiplication because the reciprocal is the inverse. Now we're going to simplify. So we can divide 60 by 30, and we can divide the two coefficients here by 30. So let's divide by 30 where possible. So that becomes 2ab on top, and then a plus b on the bottom. And then when we compare this to this, it matches. So we've done what they asked us to. We've shown that the average speed for the whole journey in kilometres per hour is the expression 2ab over a plus b.